In the previous video, we saw how to convert a text file into sentence per line format. And in this video, we'll use the file we just generated to form a list of n-grams. Using a word n-gram dataset, we can answer questions like, what is the most likely word which follows of the, for instance. Let's start by looking at the file lifeofb.sent using less. So less lifeofb.sent. Now, n-grams are just sequences of words like a treatise on. And n-grams can have different lengths. So bigrams are sequences of 2 words. And trigrams are sequences of 3 words. And as a special case, unigrams consist of a single word. Now what we're going to do in this video is to convert this text file into a list of trigrams, so sequences of 3 consecutive words. Let's quit less using Q. I've got an example here, lifeofb.trigram, and let's look at it in less. I'm going to scroll down a little bit further so that we can get to the actual text of the book. Here you can see that we do have sequences of 3 consecutive words. And like this, it is not. And this is a fragment of a sentence in the book. And below it, we have the next fragment, is not my, then the next, not my intention, and so forth. In principle, you could read the whole book from this file. So it is not my intention to write a treatise on apiculture, and so forth. Now, there are a few extra things here. These hash signs. Those mark sentence boundaries. And usually when we generate this type of an n-gram list, we only want words from a single sentence in each n-gram. Otherwise, our statistics can get mixed up. So we add these sentence boundary symbols at the start and end of sentences to keep them from interfering with each other. This is also convenient when we want statistics about what's happening at sentence boundaries, so what's happening at the beginning or an end of sentences. Another thing to notice is that we have separated commas and full stops into their own tokens. This is also typical. This way we don't treat queen at the end of the sentence as a different word than queen at the middle of the sentence, just because it happens to have a full stop glued to it. Okay, let's quit less. We'll start this by adding sentence boundary symbols at the start and end of sentences. And we can do this using sed. So let's open the file first using cat. So cat lifeofb.send. And let's pipe this to sed. I'm using this dash uppercase E option to get the extended regular expression syntax. And then the S operator. So we're going to substitute. And what I'm going to substitute is the start of a sentence. And I'm going to substitute it with a hash sign and a space. This space is needed because otherwise the hash sign will be glued to the first word of the sentence. And then let's have another sed command. So pipe this to the next sed command, which does the same at the end of a sentence. So here we're going to add a space and a hash sign. And let's look at the result in less. And as you can see, all the lines now have a start of sentence and end of sentence marker. So the next thing we're going to do is separate punctuation from words. And we can do this using sed. So let's quit less, up to get the previous command. And let's add another sed command here. So I want to match the last letter of a word Probably these are typically lowercase letters, but we can just prepare for the case where they might be uppercase letters as well. And then we're going to match a punctuation character. So I think these are all of them. And then, as you see, we are capturing the last letter of the word. So that's the first thing that we are going to substitute with. And after that, we want to add a space because we want to separate the punctuation and the last character. And then we're getting the punctuation character which matched our second parenthesis. And at the end, we need to add an option G because we want to do this for all the punctuation characters we can find in the line. And let's look at the result using less. And now, as you can see, the punctuation is no longer attached to the preceding word form. Okay, let's quit less and up to get the previous command. Now the next step is to convert the whole thing into one word per line format. And this we of course do using tr. So pipe this whole thing to tr, and we're going to just change all white space character into new lines. And then if you remember, we had this option -s for squeeze, which means that we're going to generate only one new line instead of several ones, even if we have consecutive white space characters. And let's look at how this looks using less again. Now we have a neat file of all of the tokens in our book, each on its own line. And we have separated sentences by these sentence boundary symbols. Okay, let's quit less using Q, and then let's redirect this into a file, lifeofb.unigram. And why we call it unigram is exactly because these are now actually the unigrams that occur in this book. Now, based on this unigram file, we can build longer n-grams. And the idea is that this unigram file gives the first word of our n-gram. And then when we remove the first line of this file, we get the second word. And then when we remove first and second words, we get the third word. And let's see how exactly this works. So let's open this life of b.unigram using cat. And let's pipe it to the tail command. And you may remember that this option prints you the file starting with the second line. Let's look at the result using less. So you can see that this is actually the same file, except we are missing our initial sentence boundary symbol. So it starts directly with produced. Let's quit this, and let's redirect this into a file, lifeofb.unigram +1, to note that we have now deleted the first line. And then to chop off the first two lines, I'm going to have +3 here instead of +2. And I'm going to call this line lifeofb.unigram +2. Now let's paste all of these files together. So lifeofb.unigram, lifeofb.unigram +1, and lifeofb.unigram +2. And let's look at the result using less. I'm using this -d and space option here to paste these files using space instead of the tab character, which is default. And let's see how it looks. And you can see that we actually do have trigrams here. So the hash sign here was the first word of lifeofb.unigram. Now lifeofb.unigram +1 contain all except the first line. So this is actually the second word of lifeofb.unigram. And then the +2 file contained all but the two first lines. So this is actually the third line, third word of the lifeofb.unigram. And like this, we get all of the n-grams, or trigrams in this case, in the book. Okay, let's quit less using Q, and then just redirect this into the file lifeofb.trigram. Now, to find out what is the most common word that follows the words the queen, let's use egrep first to select all the lines which start with the queen. So egrep, then start of the line, the queen, and a space. And then we're going to do this on the file lifeofb.trigram. And let's look at this using less. And here you can see all the trigrams where the first two words are the queen. Let's quit less using Q. And now to count the occurrences of each of the words, let's first sort these into alphabetical order so that we get the identical lines after each other, and then use the unique-c command to count the identical consecutive lines. And then just press enter. Now, already from this output, we can see that comma is the most common one, occurring 12 times. But if we actually want to get a list in order, we can sort this in reverse numerical order. So N for numerical, R for reverse. And this tells us that comma is the most common continuation, followed by has and and all of the rest occur a little bit less frequently.